Today, on 8th of July, we will proceed further for the meat. Today, we'll proceed further with one more property of free surfaces of liquid. Yesterday, we studied surface tension property. Along with surface tension, it is observed and experimentally proved that when liquid is in contact with solid, free surfaces at the point of contact generally are curved, either concave and the curvature other type may be convex. There is only certain liquid for which this surface remains horizontal at the point of contact with solid. So this curved nature of free surface at the point of contact is one more property of free surface of the liquid. This property we will study today. It can also be explained with the help of intermolecular theory of attraction and one more additional quantity which is called angle of contact. So today we'll proceed further to study what is angle of contact and to study the shape of the free surface at the point of contact with solid. When the surface is curved, then it is said to form meniscus, and these meniscus are of different types. So we will study the shape of meniscus. So these are the contents of today's lecture. Yesterday we studied surface tension phenomenon. This surface tension of the liquid is dependent on various factors. So, surface tension for given liquid, suppose you take water at normal temperature pressure condition, its surface tension is 72 dyne per semi. But if a slight variation means temperature of water is increased or impurities are added to the pure water, this is for pure water. But if you want to change surface tension of the water, you can use different methods because that surface tension depends on various factors. It is known for given liquid if temperature is raised above the normal temperature, tension goes on decreasing, and at one certain temperature, which is called critical temperature, surface tension total becomes zero, it vanishes. So this is the first chapter, a first factor, temperature, which affects the surface tension. So when temperature is increased, the surface tension of given liquid goes on gradually decreasing. The second factor affecting surface tension is the addition of impurity. Impurity are of three types: highly soluble, sparingly soluble, partially soluble, and insoluble. Of all these three, the given liquid shows a different behavior. If what is the matter? Dhawal always raises the hand. Have you written anything in the chat box, Dhawal? You never write in anything in the chat box. Whatever the difficulty, you write it in the chat box. Dhawal Jain. Don't raise the hand in between. So for soluble impurities, highly soluble, like salt in water, for example, then when soluble impurities are added, surface tension definitely increases. If the impurity is not highly soluble, it is sparingly soluble, partially soluble, then it is observed surface tension decreases. And if you add insoluble impurities, surface tension still more decreases. So the solubility or impurity also affects the value of surface tension. So these are the factors affecting value of surface tension. It is point number 2.4.4 on page number 39 पेज के ऊपर द फैक्टर्स अफेक्टिंग वैल्यू ऑफ सरफेस टेंशन दिए हुए हैं, वो मैंने पहले डिस्कस किए बिकॉज इट इज रिलेटेड विथ यस्टर कंटिन्यूएशन ऑफ यस्टरडेज लेक्चर. सो दैट आई वांट फर्स्ट, देन वी प्रोसीड further for angle of contact, and we will discuss how the shape of meniscus takes place. What happens when you take liquid in the container? The container is wide, thick, थोड़ा तो thick होता ही है. So outside here it is a solid also. So if you consider a molecule in the contact with the solid of the free surface का molecule मैं ले रही हूँ. So in its sphere of influence, solid molecules present, liquid molecules present, air molecules present, and fourth force is its own weight mg downwards. But what happens, air molecules are in only 1/4 sphere, so that cohesive force can be ignored due to air molecule. So the second thing is, now I have started with the point 2.4.3 का मैंने शेप ऑफ मिनिस्कस बी पार्ट चालू किया है. So remember, so cohesive force here is exerted by liquid molecule. Due to symmetry, it will be resultant cohesive force will be exactly at angle 45 degree inclined with solid surface. Force of attraction between two molecules of dissimilar material is called adhesive. So solid पूरा 180 में है, तो ड्यू टू सिमेट्री रिजल्टेंट एडहेसिव फोर्स द मोलेक्यूल एट प्लेस ए ऑफ लिक्विड गेट्स is AP. It is exactly at 90 degree with the solid surface. We will ignore raise 2. Adhesive due to air molecule negligible. Its weight mg, it also negligible. So depending on the values of these two, behavior of A will be decided. Suppose I have drawn figures. See over here. Suppose AP is greater than AC. ये जो ज्यादा है और AC कम है. So what will be the resultant force experienced by molecule at A parallelogram? This resultant will be suppose AR. उसको हम लोग AR नेम देते हैं. So this AR will lie in solid. Solid में जाता है. बराबर है. If AP is less than AC, then resultant of force experienced by A will lie within the liquid. So depending on magnitudes of AP and AC, the behavior of A will be decided. I will focus my camera. Wait for a while. मैंने पिक्चर्स ड्रॉ किए हैं, उसमें देखो, दिस इज रिजल्टेंट इज एट सॉलिड. And what happens, this resultant for the equilibrium of liquid, resultant should be always tangential. ये जो force है ना surface tension के, वो surface को हमेशा tangent होने चाहिए. तो ये tangent होना चाहिए. तो ये अगर straight रहेगा तो ये एंगल कितना होगा, 90 नहीं होगा. So that is not, ये एंगल 90 नहीं होगा. Angle between this resultant and the surface should be 90. That is the expectation for equilibrium of the liquid. Resultant should be always tangential. So what happens when AP is greater than AC? This molecule likely to move up. It moves a little up so that this resultant will become tangential. Tangential म्हणजे सर्कल है ना, ये सर्कल को टेंजेंशियल होना चाहिए. So that will then take the concave part. ये तो concave हो जाएगा, देखो. I will draw the figure once again because it is not visible. The rest figures you have to refer from the book. मैंने क्या बोला, अगर AP greater है AC से, then resultant will lie in the solid, and to have the equilibrium, the resultant should be tangential, should touch at one point. Tangential होना चाहिए, 90 degree होना चाहिए. So this moves a little down, and it will form the concave meniscus. You have to refer figure 2.19a. मैं बात कर रही हूँ 2.19a की. फिगर 2.19a 37 नंबर पे है. So what will happen? To have the tangential, the molecule like A moves a little up and it forms the concave shape, so that at this point it will be make 90 degree angle. So the molecules like A have to move on their own a little upward, and concave shaped meniscus is formed in this case. Similarly, if AP is less than AC, ये AP है ना, जो solid वाला है force, वो liquid से कम है, तो that resultant lies inside the liquid. Suppose this is resultant R, AR. अभी क्या हो जाएगा? For the equilibrium, to maintain the equilibrium, this resultant AR should be tangential. So molecules like A move a little down, so that the resultant will make 90 degree with the tangent drawn, and it will form convex meniscus. Refer figure 2.19b on page number 36. 38 पेज नंबर पे ये फिगर ड्रॉ की है, देखो आप सब लोग. इन दैट फिगर actually AC should be shown greater than AP, so that resultant AR of these two, net force due to surface tension or intermolecular forces experienced by A, will lie within the liquid, and then meniscus for this equilibrium takes concave shape. ये convex हो जाता है. All these molecules move a little down हो जाते हैं. This is the second type. Suppose sometimes what happens, depending on the nature of liquid. 1 minute. Depending on the nature of liquid, sometimes AP becomes dominant as compared to AC. लिक्विड का जो नेचर है ना, उसके हिसाब से कोहेसिव फोर्स exerted by all molecules, liquid molecules lying within the sphere of influence is negligible as compared to AP. So AP itself behaves as resultant net intermolecular force acting on A. In that case what happens? वो तो tangential ही है ना, so that surface remains horizontal. वो तो horizontal हो जाता है. वो देखो फिगर 2.19.c. So AC when becomes zero, cohesive force when becomes zero, resultant is nothing but itself AP. And if you draw tangent over here, they will be parallel. So liquid will remain horizontal. So in all these different cases, and fourth is condition for convexity and convexity. So we have to consider. So these three cases are very important. Again I repeat, you have to draw these diagrams accordingly. Only actually four forces act. Sphere of influence has three types of molecules of solid, 1/4 में of liquid and 1/4 में of air. Air molecules less in number है, So adhesive force exerted by air molecules can be negligible, can be neglected. Its weight m is very small, so fourth force weight can also be neglected. So two dominant forces, adhesive due to solid molecules and cohesive due to liquid molecules, lying in one fourth and lying in one half. Due to symmetry, adhesive will be always parallel to liquid surface. It will be at 90 degree with respect to solid surface. Liquid may be सब जगह molecule से, so due to symmetry, this SP AC will always be inclined with solid surface at an angle 45. उनकी डायरेक्शन कभी चेंज नहीं होती, ओनली मैग्नीट्यूड चेंज होता है डिपेंडिंग ऑन द नेचर ऑफ सॉलिड चोजन एंड द लिक्विड टेकन इन द कंटेनर. सो समटाइम्स AP becomes greater, then A has to move a little up. All molecules like A move a little up, and for the concave meniscus only at the point of contact. ये तो horizontally रहेंगे, उसमें कुछ प्रॉब्लम नहीं आएगा. If AC is greater than AP, then the meniscus becomes convex. So these are two main types of meniscus, and this can be explained or can be related with angle of contact. What is angle of contact? Suppose this is concave meniscus. What we have to do when you find angle of contact for the given pair, when pair changes nature of solid, ये glass container है, ये water है. आप लोगों ने अगर plastic container लिया और वाटर वैसे ही रिटेन किया, फिर भी their properties change. Meniscus का form will be concave only. But what happens that time if you draw tangent at the point of contact at the liquid surface? लिक्विड सरफेस है ना, उसके पॉइंट ऑफ कॉन्टैक्ट से को हम लोग एक tangent ड्रॉ करेंगे. This is a tangent drawn, and you measure the angle between two lines, solid surface and tangent drawn to liquid surface at the point of contact, and measure that angle from inside the liquid. This is called angle of contact theta. So when concave meniscus is formed, theta is always acute. When convex meniscus gets formed, अभी उसको हम लोगों को टेंजेंट निकालना है, तो यू विल ड्रॉ टेंजेंट लाइक दिस. At this point to this surface, at the point of contact, you have to draw tangent. You have to measure angle between solid surface and tangent drawn only from inner side of liquid. So this will be the angle. So for convex meniscus, theta is always greater than 90, and for concave meniscus, angle of contact is always less than 90. So you can relate angle of contact with nature of meniscus. If angle of contact is acute less than 90, the meniscus form should have always concave nature. For example, glass water pair. ग्लास वाटर पेयर का प्योर ग्लास और प्योर वाटर लिया तो थीटा की वैल्यू 0 होती है. सो आइडियली the free surface even at the point of contact should remain horizontal, but while in practice we never take pure glass or pure water. हम लोग टैप वाटर लेते हैं ना एक्सपेरिमेंट करते समय, तो उसमें कॉन्टिमिनेशन होता ही है, इम्प्योरिटी ऐड होती है. सो थीटा expected is 0, but that time theta is greater than 0 but acute. And that time for common water glass pair, we instead of straight line horizontal surface, you will get a little concave surface. If you take the case of mercury, अगर mercury लेते हो, suppose this is a mercury, तो mercury क्या है, it doesn't weight the glass, कभी चिपकता नहीं है ग्लास को. तो क्या होता है, angle of contact always forms a convex meniscus, and hence angle of contact is always obtuse. Angle of contact is the angle between solid surface. This is one line. Solid surface reference line है. You have to draw tangent at the point of contact. को टेंजेंट ड्रॉ करना है, बट फॉर द फ्री सरफेस को टेंजेंट ड्रॉ करना है, एंड यू हैव टू मेजर दिस एंगल इनसाइड द लिक्विड. सो व्हेन एंगल ऑफ कांटेक्ट इज एक्यूट, concave meniscus is formed and liquid taken is weighting the given solid. It weights the solid, it weights the container, वो चिपक जाता है. For angle of contact obtuse, convex meniscus is formed and that liquid does not weight solid. ऐसा हम लोग इन्फरेंस ड्रॉ कर सकते हैं. So depending on molecular theory and the concept of angle of contact, you can explain the shape of meniscus formed by free surface at the point of contact with the given solid. This angle of contact for given solid liquid pair is constant. अगर आप लोगों ने प्लास्टिक और वाटर, प्लास्टिक भी कर लिया, उसमें वाटर पोर किया, तो उसका थीटा विल बी डिफरेंट फॉर द पेयर वाटर टेकन इन ग्लास कंटेनर. ग्लास के अगर तुम प्लास्टिक रिप्लेस करते हो तो दोनों का थीटा की वैल्यू अलग अलग आ जाती है, लेकिन फॉर गिवन पेयर दैट थीटा for the pair at normal temperature pressure condition is always constant. So these are the properties. This is large quantity of liquid. हम लोगों ने ये liquid ज़्यादा quantity में लिया है. If I take its smaller quantity and if I pour it on a solid surface, एक solid surface लिया, suppose glass, or only I will pour a small quantity, ऊपर से मैंने लिक्विड डाला है, ओनली अ स्मॉल क्वांटिटी. व्हाट इज द ऑब्जर्वेशन? वो क्या होता है, अगर स्मॉल क्वांटिटी ऐड करते हैं तो इधर ड्रॉप फॉर्म हो जाता है. आई एम मूविंग टू पॉइंट नंबर, देखो आप लोग, बी, पेज नंबर 38 है ना, 38 पेज नंबर का, शेप ऑफ लिक्विड ड्रॉप्स ऑन सॉलिड सरफेस, या ये पार्ट मैंने चालू किया है. So ये part मैं चालू, I already have started, and be sure for that. What happens here when a smaller quantity is poured? That liquid takes the shape of either drop or it spreads. Page number 38, 38 बोला मैंने. Can you tell है ना, उसके नीचे देखो, शेप ऑफ लिक्विड ड्रॉप्स. लिक्विड की क्वांटिटी अगर ज्यादा है तो फ्री सरफेस फॉर्म होगा, उसका एरिया बहुत होगा, तो उस टाइम का बिहेवियर यू हैव टू एक्सप्लेन ऑन द बेसिस ऑफ एंगल ऑफ कांटेक्ट. अभी अगर स्मॉल क्वांटिटी ऑफ लिक्विड मैंने ली तो क्या हो जाता है, ड्रॉप तैयार हो जाएगा, नहीं तो लिक्विड विल स्प्रेड, इट विल गेट फ्लैटन. Either it will form a drop or it will spread on this. वो flow हो जाएगा depending on the values of forces of surface tension. This can also be explained on the basis of molecular theory. अभी क्या होता है देखो, मैंने अलग अलग टाइप्स ले रही हूँ. 3 forces act. अगर मैंने लिक्विड किया, यहाँ पे pour किया, तो क्या होता है, इट विल टेक आइदर कॉन्केव कॉन्वेक्स शेप, इट विल टेक कॉन्केव शेप, और इट विल गेट फ्लैटन. ये पूरा का पूरा फ्लैटन हो जाता है. हाँ, ये ड्रॉप है ना, ये ऐसा रहेगा, नहीं तो ये ऐसा रहेगा, नहीं तो पूरा फ्लैट हो जाएगा, बिखर जाएगा, स्प्रेड हो जाएगा. सो हियर इफ यू फाइंड एंगल ऑफ कॉन्टैक्ट एंड यू मेजर इट फ्रॉम द साइड ऑफ लिक्विड, ये लिक्विड है, ये सॉलिड है, ये सॉलिड से हम लोग इधर से एंगल ऑफ कांटेक्ट मेजर करेंगे. टेंजेंट ड्रॉ करना है एट द पॉइंट ऑफ कांटेक्ट. So this angle will be then less than 90. So if angle of contact is acute, then the drop form will take convex shape. Convex shape तैयार हो जाता है drop का. If this is the case, अभी tangent draw करो at the point of contact. ये टच हो रहा है. Solid से from inside the liquid, this we have to measure. So theta, then it will become obtuse, and when this becomes obtuse, the drop form will take concave shape. ये ऐसा हो जाता है नीचे से, और नीचे से ये वो ऐसा हो जाता है. ये ना, ये ऊपर से कॉन्वेक्स आएगा और ये ऊपर से, यानी कि ये एडिशनल है. और स्प्रेड कभी होगा इफ थीटा बिकम्स जीरो. थीटा की वैल्यू अगर जीरो रहती है तो इट विल स्प्रेड ओवर द गिवन सरफेस. So this liquid drop shape you can explain on the basis of theory of angle of contact. Remember, if angle of contact for given liquid solid pair is acute, then when a small drop of small liquid is poured on given solid, it takes convex shape. ड्रॉप का शेप कॉन्वेक्स रहता है. इधर ड्रॉप का शेप कॉन्केव आएगा इफ थीटा इज ग्रेटर देन 90 एंड इट विल स्प्रेड ओवर इफ थीटा इज इक्वल टू 0. So these 2 points we can explain on the basis of angle of contact. So what happens whenever there is change in shape? देखो अभी बड़ा लिक्विड लेते हैं समझने के लिए. अगर इट इज कॉन्केव, हियर तो हॉरिजॉन्टल है, it is horizontal. So if you select 2 points, upper surface, a point just above the surface and a point just below the surface, ऐसे मैंने पेयर चूज की. हॉरिजॉन्टल है यानी कि प्रेशर एट ए और प्रेशर एट बी दोनों सेम रहेंगे, बट इट इज नॉट द केस फॉर द कर्व्ड surfaces. If you select 2 points A dash B dash, then it is observed pressure at A dash is always greater than pressure at B dash. We always get excess pressure on the side of concave surface, and that excess pressure is explained by scientist Laplace. So in tomorrow's lecture we'll proceed further to study pressure difference across the curved surface, and we will find the expression for difference in pressure using Laplace's law. So I am closing today's meet. You have to join the other one.